Hello. Now we're going to do the third exercise in the mortgage exercises spreadsheet. Now this exercise asks us to do the same thing as exercise 2 in that we're track the balance of a mortgage as it's paid off. However, we're going to do it in a different way. We're going to still use our basic timeline. This side I'm going to set up traditionally and just use plus the prior cells to build it out. We need one more to get to 15. And what we're going to do is we're going to recognize that a mortgage is really just an annuity that changes its period every year. And you'll see what I mean by that in just 1 second. Because the first thing we need to do is actually set up our payment. We saw this in the last tab, but we want to set up our payment based on our rate, our number of periods initially, and that initial outstanding balance. So $9.18 is going to be our payment, just like in the last example. Now our beginning balance, here's where we can see that the annuity formula works for every year in this mortgage schedule. And so here I'm going to use the PV function, right? It's going to calculate the present value of an annuity. Our rate is going to be 4.3%. Our number of periods is 15. I'll lock that. And our payment is going to be negative $9.18. And we get that $100 balance. Right? That makes sense. We had 15 periods. So what do we need to change to go from year 1 to year 2? Well, what changes is you now only owe that same payment for 14 years. So now we need a way to take that formula, copy it down, and now change the number of payments. And actually have to check to make sure we lock everything. It looks like I didn't lock everything properly. Actually, everything slid down. Actually, C8 was the only one I didn't lock. So let's go change that to C7 and lock it. All right, so we have $100. But now we need to change the number of periods. So what we want, instead of having 15 as this or number of periods argument, we need to actually subtract how many years we've had so far. So in this case, we can subtract off the fact that we've had 1 prior year. And so we can subtract the previous year away. So now instead of having 15 periods, we have 15 minus 1, or 14 periods. And now we only owe 95.12 remaining. And now that same formula we can copy down. If we go 1 more year, we see that it's $90.02. If we switch back to our previous model, that's exactly what we saw as the beginning balance in year 3. So now that same formula can be used all the way down to period 15. And there we see at the very end, we owe $8.18, or essentially an annuity that makes 1 payment of $9.18, and it's just over 1 year. So what you can see is a mortgage is really just a series of annuities if we calculate the mortgage schedule. You have a 15-year annuity, then a 14-year annuity, then a 13-year annuity. And so we can leverage the present value function this way if we want to calculate the balance remaining in an annuity over time. Our last step is let's just make sure we get the sum of our beginning balances right. So we can sum up that column, and we see that we do have the correct answer.